Question number 15 deals with probability and statistics. So something you might want to address today or this week for the high school lesson plans. Or you could also do 7th or 8th grade lesson plans on probability and statistics. And I detailed everything in that document I posted up as a module in your module 6. But I didn't write down a graph or a chart. So I think that would be helpful. So if you understood this part, class, you had to calculate two means, okay? So class X, the mean was 5. Class Y, the mean was 5. And you're going to do something to these means. And to do these things, I like to put them in a table, okay? So if we write down, this is just for class X here, okay? We're not really dealing with class Y right now. All right, so class X, the data points that we had, don't have them, are, I don't have the question, I'm sorry. But let's say the first data point is 1. I hope it is. Okay, so what you do is you take that first data point and then you're going to list the other 4 points here, okay? And you're going to subtract it from your mean. That's going to give your deviation or your difference, okay? Deviation is like your difference from the mean. So 1 minus 5, that's -4, all right? Then you're going to find the absolute value of that deviation. So again, here's your data points X. Your deviation is X minus X bar. X bar is the fancy way to represent your mean. And then your absolute deviation is the absolute value of X minus X bar, okay? So the absolute value of a -4 is a +4, and that's the answer for that point. Now you have to tediously go through each point, and I think the second point is, what is it, 3? Okay, 3, that's +3. So you take that number, you subtract it from the average, which was 5, or the mean, so you get 3 minus 5, -2. The absolute value of -2 becomes +2, right? Then what you're going to do is you're going to take these values that you just calculated, the absolute deviation values, and find the mean, or the average, to get mean absolute deviation, also known as MAD, right? So MAD is what you want to calculate. And let's see, I think I wrote down the answers for that. And I'm sorry, I don't have all the data points, so I can't do it out. So if you get stuck, just post it on the discussion board, and we'll go from there, and I'll get more detailed once I have the whole answer here. Oh, actually I have it. Now let me just plot this real quick so that you can see what it looks like as a line plot. All right, so once we do that, we should be all set. So the problem with this being cumbersome is that not only did you have to calculate all the class X absolute deviations and then take the mean of those, you had to also do it for Y, and then you're going to compare the two MAD values. All right, but we're going to plot now 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to plot the number of books read for class X, okay? And so what we have is someone read 1 book, someone read 3 books, someone read 5 books, someone read 7, someone read 9, okay? We're going to take, this is just kind of like a box plot overlying a line plot, okay? A box and whisker plot, I'm sorry. All right, so you're going to take the median, which is the middle value. So I always use the markers for my students so they can visualize it better. Let's just see if this will work out. All right, so I go like this. I physically go, all right, here's the first point, the next one in, and the middle one. The middle one is 5. That's our median. So we put a line. Then, now there's actually 2 ways to do this, but I'm going to pretend one way uses this as the last point, and this is the other last point, the end point, and then you take the median of that. We're going to do that. Okay? So you're taking the median of the lower half. Okay? So this is the lower part of your data. And then you're going to take the median of your upper part. Now just to confuse you, there are some people who don't count this as the median. They would count, they don't count this in determining the median over here. So they would start with this point and find the median here, or anything under that median. But we're going to use this as one of the endpoints. So anyway, I know this is confusing, but now you have 3 medians, 2 endpoints, and it works out because there's only 5 points. But what you're going to do is, if we made this line plot now into a box and whisker plot, we have whiskers on the end. Our minimum value is 1. Our maximum value is 9. Our median value is 5. And then you can see that the boxes form like the inner 50% of your data. This is your lower quartile. You see how everything's divided up into like quarters? This is the first quarter, second, third, fourth. This is the upper quartile. Okay, the second and third make your middle quartiles, okay? So middle, or we'll call it inter, right? So your inter quartile is the middle numbers, and your range is always your maximum minus your minimum. So your maximum is 7, your minimum is 3, so our interquartile range is 7 minus 3, or 4. Okay? If we did that to the other one, and we compare, so that's a big number, 4, right? In statistics anyway. If you compare this to your other, your data set with, this is class X, the IQR for class Y, you will see, because the numbers are all close, all of the kids pretty much read 5 books, I think. Is that right? Yeah. So that means there's not a lot of range. So therefore, this is why we look at this information. You could say, there's more variability in class X, all right? More reading abilities in that class, because some kids read 9 books, some kids only read 1, so it's a big difference, whereas all the kids in the other class are pretty much on the same level. All right? I hope this helped, and email me if you have problems or questions. Thank you.